So today we are going to learn about insolation from my notes. So let's start. The question is, what is insolation? Describe the factors affecting distribution of insolation. So we'll go with the meaning. So insolation meaning, the Earth's surface receives most of its energy in short wavelength. The energy received by the Earth is known as incoming solar radiation, which in short is termed as insolation. I'll be reading everything. I might not explain because I don't have much time and I have to cover it. So insolation can be defined as the radiant energy received from sun transmitted in a form analogous to short waves. Insolation can be defined as radiant energy received from sun transmitted in a form analogous to short waves. The sun is a great engine that drives wind on Earth's surface, ocean current, and exogenic or denominational process, and ultimately sustain life in biosphere. So insolation can also be defined as radiant energy received from the sun transmitted in a form analogous to shortwave. The sun is a great engine that drives wind on Earth's surface, ocean current, exogenic or denominational process, and ultimately sustain life in biosphere. Earth is a geoid resembling a spear. The Earth's rays fall obliquely at the top of atmosphere, and Earth intercepts a very small portion of sun's energy. On an average, the Earth receives 1.94 calories per square centimeter per minute at the top of its atmosphere. Sun is a great engine that drives winds on the Earth's surface in ocean currents. Insolation is responsible for the movement of air currents through changes in the pressure gradient. It also drives hydrological cycle through evaporation and precipitation. Okay. Solar constant, so the amount of solar radiation or solar energy received on unit area of surface facing the sun at average distance between sun and earth is also more or less constant and is called solar output. Solar constant is the amount of solar radiation or solar energy received on unit area of surface facing the sun at an average distance between sun and the earth is more or less constant, is called solar constant. Okay, so देखो, I think I did some error while writing this. Solar constant क्या होता है? Basically, it is amount of solar radiation, solar energy received on unit area of surface of Earth facing the sun at an average of an average distance between of which the average distance. अच्छा ठीक है. Solar constant is the amount of solar radiation or solar energy received on unit area or surface facing sun at of which average distance between sun and earth is also more or less constant and is called solar constant. Unit of insolation, watts per square meter. Solar output received at the top of atmosphere varies slightly in a year, due to variation in distance. Solar output received at the top of atmosphere varies slightly in a year due to variation in distance. During its revolution around the sun, the Earth is farthest from the sun. 152 million किलोमीटर on 4th July. This portion, अच्छा ये बेसिकली नहीं करना है अभी. पहले देखो, while writing the answer first we write the meaning. उसके बाद हम ये सोलर कांस्टेंट डिफाइन करेंगे. उसका यूनिट क्या होता है इंसुलेशन का. सोलर आउटपुट क्या होता है? इट इज सोलर आउटपुट रिसीव्ड एट द टॉप ऑफ एटमॉस्फेयर वेरी स्लाइटली. वो नहीं इंपॉर्टेंट है. इंपॉर्टेंट क्या है फिर कि फ्लो ऑफ सोलर रेडिएशन ऑफ द अर्थ एज अ होल रिमेन्स कांस्टेंट बट अर्थ अमाउंट रिसीव वेराइज फ्रॉम प्लेस टू प्लेस. ठीक है. अब हम आते हैं फैक्टर्स अफेक्टिंग डिस्ट्रीब्यूशन ऑफ इंसुलेशन विच इज इंपॉर्टेंट. सो इंसुलेशन रिसीव्ड एट द अर्थ सर्फेस डिक्रीज फ्रॉम इक्वेटर टुवर्ड्स द पोल बट देयर इज अ टेम्परल वेरिएशन ऑफ इंसुलेशन रिसीव्ड एट डिफरेंट लैटिट्यूड एट डिफरेंट टाइम्स ऑफ द ईयर. Following are factors affecting distribution of insolation: angle of sun rays, length of day, distance between the sun and the earth, sunspots, effect of atmosphere. So angle of sun rays, effect of sun rays on the distribution of insolation. So since the earth is round, the sun rays strike the surface at different angle at different places. The angle formed by the sun rays with the tangent of the earth circle at any point is called the angle of incidence. In case of vertical rays, the angle of incidence is large, hence the rays are concentrated in smaller areas, giving more insolation at that place. Oblique rays have small angle of incidence and sun rays have to heat up greater area, resulting in the loss of insolation. ठीक है. As greater is the amount of reflection and absorption by the अच्छा देखो, रिजल्टिंग इन लॉस ऑफ इंसुलेशन रिसीव्ड बिकॉज द लॉन्गर द पाथ ऑफ द सन रेज reduce the amount of reflection and absorption of the heat by the atmosphere. ठीक है, उसके बाद भी हैव दिस, यहाँ पे रखते हैं. So we have these points where it is written that when the sun is high above the horizon near the noon, for example, the sun's angle is greater and so insolation will be greater. At equinox, sun rises directly to the east and sets directly to the west. At noon, sun is positioned at an angle of 50 degrees above the horizon in southern sky. At June solstice, sun's path rises much higher. At noon, it will be 73.5 above the horizon. ठीक है, एट इक्विनॉक्स सनराइज, देखो पहले तो ये लिखना है कि व्हेन द सन इज हायर अबव द होराइजन और नियर द मून, द सन एंगल इज ग्रेटर एंड सो इंसोलेशन विल बी ग्रेटर. एट इक्विनॉक्स सन rises directly to the east and sets directly to the west. At noon, sun is positioned at an angle of 50 degrees above the horizon in southern sky. At June solstice, sun's path is much higher. June solstice में sun's path is much higher. At noon, it will be 73.5 degrees above the horizon. At December solstice, the sun's path is low in the sky, reaching only 26.5 degrees above the horizon. June solstice 73.5 degree and December solstice 26.5 degree. Now, angle of the sun rays decreases poleward on as vertical rays bring more insolation than oblique rays. Oblique rays are spread over maximum area while vertical rays spread over minimum area. Oblique rays have to pass through thicker portion of atmosphere than the vertical rays. Thus, amount of solar energy lost due to reflection, scattering and absorption increases. ठीक है. With increasing distance of the path covered by the sun rays to the atmosphere. Now, length of the day. So the length of the day varies at all places except at equator. Length of the day varies at all places except at equator due to inclination of Earth's axis and parallelism. The length of the day varies at all places except at equator. Length of the day varies at all places except at the equator due to inclination of Earth's axis, its parallelism and Earth's rotation and revolution. The length of the day varies at all places except at equator due to inclination of Earth's axis and parallelism and Earth's rotation and revolution. ठीक है, inclination of Earth's axis, parallelism, Earth's rotation and revolution. Inclination of Earth axis, parallelism, Earth's rotation and revolution. Length of the day increases poleward with north march of the sun, northern march of the sun in the northern hemisphere, while it decreases in the southern hemisphere at the time of summer solstice. Summer solstice के टाइम पे क्या होता है? The length of the day increases with poleward. Length of the day increases poleward. Length of the day summer solstice के टाइम पे length of the day increases poleward. Summer solstice के टाइम पे length of the day increases poleward with northern march of the sun in northern hemisphere, and it decreases in the southern hemisphere with the southern march of the sun. ठीक है. So length of the day increases poleward with northern march of the sun in the northern hemisphere, while it increases in the southern hemisphere at the time of summer solstice. So length of the day increases poleward with northern march of the sun in northern hemisphere, while it decreases, ठीक है, in the southern while it decreases in southern hemisphere at the time of summer solstice. Length of the day increases poleward with northern march of the sun in northern hemisphere, while it decreases in southern hemisphere at the time of summer solstice. Length of the day increases from equator poleward in the southern hemisphere, but it decreases in the northern hemisphere at the time of winter solstice. Length of the day increases from equator poleward in southern hemisphere, but it decreases in northern hemisphere at the time of winter solstice. Length of the day increases from equator poleward in the southern hemisphere, but it decreases in the northern hemisphere at the time of winter solstice. Length of the day increases from equator poleward in southern hemisphere, but it decreases in the northern hemisphere at the time of winter solstice. थोड़ा सा condition वही reverse हो गई है. Then in spite of the longest length of the day at the poles, insolation becomes minimum because in spite of the longest length of the day at the poles, insolation becomes minimum. दिन लंबा होता है poles पे, but still insolation minimum होता है because sun's ray become more or less parallel. Sun's ray become more or less parallel. Sun ray become more or less parallel. Sun ray become more or less parallel to the ground surface, and then ice reflect most of the solar reflection. Sun ray becomes parallel to most of the sun ray become more or less parallel to the ground surface. Sun rays become more or less parallel to the ground surface, and I reflect most of the insolation. Ice reflect most of this insolation. So what happened? In spite of the longest length of the day at poles, it received less insolation. Why? Because sun rays are almost parallel to the ground surface, number one, and number two, I reflects most of the insolation. It is important to know the duration of the day is 6 months at the North Pole. अच्छा, so day का duration 6 month होता है North Pole पे, while night is 6 months at the South Pole during this period. Now distance between Earth and Sun is the third factor. So पहली चीज़ की distance between Sun and Earth changes due to the course of year because Earth revolves around in the elliptical orbit. The average distance between the Sun and the Earth is 93 million miles or 149 million kilometer. Average distance 93 million miles, 149 million kilometer. Average distance 93 million miles, 149 million kilometer. Average distance 93 million miles, 149 million kilometer. Average distance 93 million miles. Average distance 93 million miles and 149 million kilometer. Average distance 93 million miles and 149 million kilometer. Average distance 93 million miles or 149 million kilometer. Then at the time of perihelion on January 3, the Earth is nearest to the Sun. At the time of perihelion on January 3, the Earth is nearest to the Sun. At the time of perihelion on January 3, at the time of perihelion on January 3, Earth is nearest to the Sun. That is 91.5 million kilometer or 147 million, 91.5 million miles or 147 million kilometer. 91.5 million miles और 147 million kilometer. इसे हम क्या बोलते हैं? पेरीहीलियन. 91.5 million miles और 147 million kilometer. 91.5 million miles और 147 million kilometer. 91.5 million miles और 147 million kilometer. 91.5 million miles और 147 kilometer. 91.5 million miles and 147 kilometers. 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 ठीक है. फिर at the time of perihelion था. ठीक है. Then अब हम आते हैं एपीहीलियन के टाइम पे. क्या होता है? when sun is farthest from the when the earth is farthest from the sun, so the distance is 94.5 million miles. 94.5 million miles or 152 million kilometer. 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 ठीक है. फिर हम लोग कहते हैं as per the rule at the time of perihelion when it is nearest to the sun should receive maximum insolation while it should receive minimum insolation at the time of aphelion when the sun is at greatest distance. ठीक है. तो रूल के हिसाब से ऐसा होना चाहिए कि जो सन है ना, सन शुड रिसीव वो अर्थ शुड रिसीव मैक्सिमम इंसोलेशन अच्छा अर्थ एट द टाइम ऑफ पेरीहीलियन व्हेन इट इज़ नियरेस्ट टू द सन. जब पेरीहीलियन के टाइम पे जब अर्थ नियरेस्ट होता है सन के, तो इसके पास मैक्सिमम इंसोलेशन होना चाहिए और मिनिमम इंसोलेशन चाहिए एपीलियन के टाइम पे जब वो ग्रेटेस्ट डिस्टेंस पे था. बट मानता हूँ जनवरी में हम लोग देखते हैं कि व्हेन द सन इज नियरेस्ट टू द सन देयर इज विंटर सीजन इंस्टेड ऑफ समर सीजन in another hemisphere due to low amount of insolation received. क्या होता है कि विंटर सीजन होता है क्योंकि बहुत कम इंसोलेशन रिसीव होता है. ऑन द अदर हैंड month of July when the earth is farthest from the sun there is summer season in the northern hemisphere due to high amount of insolation received. This observes the factor that angle of sun rays and length of day play more dominant role in distribution of insolation than the factor of varying distance between earth and sun. Angle of sun rays and length of day play more dominant role in distribution of insolation. Angle of sun rays and length of day play more important role. ठीक है. Angle of sun rays and length of day play more dominant role in distribution of insolation than the factor of varying distance between earth and sun. Sun's